Alright, what I'm going to do is I'm going to do an introduction to redox balancing because we're going to do this in class tomorrow, but this will help if you have kind of a familiarity with it based on watching this video. There are 7 steps in redox balancing. We're going to highlight them and go through so you can see them. And this should give you a really good fundamental idea of what we do when we redox balance. It's just about counting is really what it is. So the first thing is we first split the original equation into 2 half reactions. One half reaction is going to be reduction. One half reaction is going to be oxidation. How do we do that? Well, it's kind of like in class today. We did the oxidation number breakdown in class today. So if you look, if I assign oxidation numbers to this, I would say Fe is 2 plus. This Fe is 3 plus, the same charge as the ion, and this is 3 plus. We know oxygen is 2 minus here. When you do the oxidation number calculation or solving for it, you realize that the oxidation number of that is 6. Remember, in a redox reaction, one number goes up, one oxidation number goes up, one oxidation number goes down. In this case, Fe goes from plus 2 to plus 3. That makes that an oxidation. Then, chromium goes from 6 to 3 plus. That is a reduction. So when we talk about the half reactions, the way we figure out what the half reactions are is you assign oxidation numbers to see how they change, and that lets you know to split them into 2 half reactions. So that's step 1. Step 1, really, you assign the oxidation numbers and then just split them based on that. So then for each half reaction after that, you have to do certain steps. And so we're going to go through them right now. First step is balance all other elements except H and O. So we go through and we balance all the other elements. So let's go back to our equation. Well, let me split them into the half reactions. So I'm going to go Fe 2 plus, arrow, Fe 3 plus, and then on the bottom, do it a different color, Cr2O7 2 minus, arrow Cr 3 plus. So my first step is balance all the other elements. Well, if you look here, I have Fe 2 plus, Fe 3 plus. There's one Fe on the left, one Fe on the right, so I'm good with that. Then I look right here. Chromium, I have 2 chromiums right there. That means I have to put a 2 here to balance all the other elements. So now I've done step 2. Step 2 is balance all other elements except hydrogen and oxygen, which leads us to step 3. How do we balance oxygen? We balance oxygen by adding water. We add water, or H2O, to basically add O's to whatever side we need, and all we're doing is counting oxygen. That's all you're doing. So we go back over here. In the first one, the Fe, the oxidation, there's no oxygen anywhere on either the left or the right, so it doesn't matter. On the bottom equation, if you look, I have 7 oxygens right there, which means I'm going to need to add 7 waters on that side. By adding 7 waters, I added 7 oxygens. So now the oxygen is balanced. Next step is I have to balance the H's by adding H plus. So now I balance the H's by adding H plus. So I go back to my original equation. Fe2 plus and Fe3 plus have no H's, therefore they don't need to be balanced. If I look at the bottom one, if you notice right here, I have the coefficient and the subscript multiplied together. I have 14 H's, which means I have to put another 14 H's on this side. So I add 14 H plus, and now all my H's are balanced, which brings me to my next step. Balance the electric charge by adding electrons. The charges on both sides of the equations have to be balanced. And what you do is you always add electrons to the lower number of charge. So we always add electrons to the side with the lower charge. So the lower side always gets the electrons. You add electrons. So if I look here, the charge, I'll do this in green. The charge is the charge here times the coefficient, which happens to be 1. So overall, this side has a charge of 2 plus. Here, coefficient's 1, because we care about the coefficients when we're counting the number of atoms and when we care about the charge. It's coefficient times the charge value. 1 times 3 plus means this side is going to be 3 plus. So what I do when I go to add electrons is I add electrons to the side that is higher. Did I say lower in the other one? Higher. Whoops. Scratch that originally. You add electrons to the side that's higher. So if you look here, 3 plus and 2 plus in this Fe one right here. This side, the right side, has a charge of 3 plus. So I add 1 electron. As soon as I add that electron, it's 1 times the negative charge, means that this side is now 2 plus and the charge is balanced. So whenever we add electrons to the higher charge side, not the lower side. Now I have to do the same thing on the bottom here. Well, when I look, water has no charge. So if I look right here, there's no charge for water, so that's 0. But I have a 2 and a 3 plus here. So overall, this side has a total charge of 6 plus. Then I get to this other side. I have 14 times the 1 is going to be 14 here. And then 1 times the negative 2 is going to be negative 2. When I add the 2 together, I'm going to end up with a total charge of 12 on this side. By adding those 2 together, I end up with a total charge of. So one side is plus 12, one side is plus 6. The trick to adding electrons is you add the same number of electrons that allows the charges on both sides to be equal. So I'm going to add 6 electrons here. And that 6 times the negative 1 will bring this down to positive 6. So when we go to balanced charge, that's what we're talking about. You take the coefficient times the charge of an ion, total it on the left side, total on the right side, and when you're doing redox, they have to balance. Okay, I go back to my next step. Multiply the 2 equations, if needed, by coefficients to make sure the electrons are equal. The whole point of a redox reaction is to get the electrons to cancel. So you want the electrons to cancel. So what you do is, if I look right here, this has a coefficient of 6. So I have 6 electrons here, 1 electron here. I have to get the coefficients the same. So what I'm going to do is I'm going to take the top equation and multiply by 6. So I'm going to multiply this whole thing by 6. This is going to be 6 here, 6 here, and 6 here. So then what I notice is now my electrons cancel. So you multiply, lowest common multiplier, get the electrons to cancel, you cancel them out. The last step is to simplify the equations. If you have something on the right-hand side and the left-hand side of an opposite equation, if they're on opposite sides, you can cancel them or simplify. In this reaction, this is a pretty simple one. I don't have anything on one side or the other that's the same that can cancel. So all I'm going to do is take everything that's remaining and basically, like a Tetris game, it's going to fall down to the answer line. So this 6, and it has to be in no particular order. You can put it in any order you want as long as the reactants are on the reactant side, products on the product side. So I'm going to say 6 Fe2 plus 14H plus Cr2O7 2 minus arrow 2 Cr3 plus 6 Fe3 plus 7 waters. That is my final answer. My redox balancing is done. One last thing you can do to make sure that you can check your work to make sure you do this correctly is when you finish, the charges on both sides of the equation have to be equal. They have to be. So let's take a look. If I go to figure out the charges, I look on this side. 6 times a positive 2, I'm going to get 12 here. 14 times a positive 1 is going to be positive 14. And then 1 times a negative 2 is going to be negative 2. For an overall charge value of 24. Positive 24. Then I go over to the right-hand side. 2 times a positive 3 is going to be positive 6. 6 times A3 is going to be positive 18. That means I have 24 on this side, 24 on this side. Therefore, I know I can, with confidence, sign my name and be proud that I balanced the redox correctly. Key things you want to make sure that you address. We balance oxygen on the bottom by adding water. We split the two half reactions by using oxidation numbers. The one that goes up is an oxidation. The one that goes down is a reduction. The side that gets the electrons added to it is always the side with the larger charge. You can check your work in redox balancing by totaling the charge on both sides after you have the finished equation. The order that you write the species does not matter. You can write it in any order as long as the reactants are on the right side, they stay on the right side of the, or reactants on the left side of the arrow, the products are on the right side of the arrow, and you're good to go. And that is an intro to redox balancing. You need to bring this sheet with you tomorrow, and we're going to do it step by step, baby step style, and balance some redox reactions. All right? Hope you guys have a nice evening. I will see you tomorrow. Make sure you know the answers to these questions. You never know when you might be asked these questions at the start of class, like a pop quiz. Not saying, I'm just saying, who knows? You never know.